This video provides instruction on how to calculate simple and compound probabilities from frequency trees and two-way tables. So here we have an example with a frequency tree, and the first event is the batter in baseball is either a right-hand batter or a left-hand batter. The second event is the pitcher is either a right-hand pitcher or a left-hand pitcher. So if you look at the first branch, there's 1,193 right-hand batters. There's 417 left-hand batters. And then you go to the second branches, and you'll see the totals add up to this number here, right? The right-hand pitchers is 500, 693 left-hand pitchers facing these right-hand batters, so 1,193 total. Same thing down here, the 417 left-hand batters. Who do they face? They face the 255 right-hand pitchers and 162 left-hand pitchers. So now to find the probability that someone is a right-hand batter, we're looking at the 1,193 out of the total for the first set of branches here. So that's 1,193 divided by 1610, which is the total, which is about 0.7409 or 74.1%. Now, the probability that you're a left-hand batter, it's still the first branches here. So that's the 417 out of the total, which is the 1,610, which is 0.259 or 25.9%. Now let's look at a compound inequality, or not inequality, compound probability. Probability that a right-hand batter and a left-hand pitcher. So we're going to go this branch here, the right-hand batter, and then we're going to go down this branch here, the left-hand pitcher. So it's 693 out of the total. The total again is 1,610, right? So it's going to be 693 divided by 1610, which is 0.4304, which is 43%. Okay, look at the last one here, probability left-hand batter and left-hand pitcher. So we're going down this branch here, left-hand batter, and then we are going left-hand pitcher, going down this branch right here. So you can see there's a total of 162. So it's 162 out of 1610, which is 0.1006, which rounds to 10.1%. Now let's look at the same data in a two-way frequency table. So here we have the rows are made up of the batters, right? Right-handed batter, the total is 1,193. Left-handed batters, the total is 417. Then you look at the columns, the right-hand pitchers, total 755 right-hand pitchers. Left-hand pitchers, the total is 855. And then I want you to notice the bottom right corner, the total, 1610, both the rows and the columns add up to 1610. In other words, 755 plus 855 here is 1610, and 1,193 plus 417 is 1610. So let's use this now to find probabilities. So the probability right-hand pitcher, so right-hand pitcher is right here. There's 755 out of the 1610. So that's 0.4689, which gives us 46.9%. Probability left-hand pitcher, again, look at this column here. Our total is 855. So it's 855 out of the 1610, which is 0.531 or 53.1%. Now let's look at the compound probabilities with and. Probably a right-hand batter and a right-hand pitcher is 500 over 1610. Where do we see that? Here's the ands, right? It's the overlap, right-hand pitcher, right-hand batter, right? So that's 500 out of the total 1610, which gives us 31.1%. We want to find the probability of a left-hand batter and a right-hand pitcher. Left-hand batter, right-hand pitcher is right here, 255. So that's the 255 out of 1610, which is 0.1583 or 15.8%. Hope this video was helpful. Thanks for watching.